Okay. So with the Casagrande extended soil classification system, we use the PSD, the Atterberg limits, to classify the soils. And the prefixes that we mostly see, we see G to represent gravel, S to represent sand, M to represent silt, C for clay, O for organic. We have our H to be high plasticity, L to be low plasticity, and P to be poorly graded, and W to be well graded. So with that, we have a chart we use to do the classification. We won't go much deeper into it because that's not the focus for today. It is a small something. You can just look at it and determine the type of soil it is. But the most difficult, or should I, it's not difficult, it's simple, but it comes often, and it's the most current. That's the unified soil and then the AASHTO. It is similar to the Casagrande's soil classification system. It's like a build up on the Casagrande soil classification system. This one uses a grain size distribution and Atterberg limits for classification. So with the unified, we group soils into a coarse grained, a fine grained, and highly organic soils. Okay. So with the unified, I said earlier that we group them according to a coarse grain, and under the coarse grain, we have two soil classifications under it. We have the sand and we have the gravel, constituting the coarse grained soils. And we have the fine grained soils too. Under that, we have our silt and our clay. Okay. So this is going to give us a guideline on the classification we are going to do. So we should note that the coarse means, or the coarse grained means gravel and sand. And the fine grain is silt and clay. Okay. Let's move on. So the symbols, as usual, it represents, we have the G representing the gravel, the S, the sand, M to be silt, C to be clay, O to be organic. And we have a newly introduced symbol PT, which is a peat. H still represents the high plasticity, L low plasticity, and the gradations. We have W to be well graded and P to be poorly graded. So yesterday we were doing the PSD and we drew a PSD curve, the particle size distribution curve. It was like this. We calculated the D10, D30, and the D60. And we used that to check the CU and the CC. And remember, I told you to go and look for the interpretations to them. So here is the interpretation. So if you have your CC value or your CU value between 1 and 3, the unified system is telling us that it is within the range of well-graded soil. And if you have the CU to also be greater than 4, then you are 100% well graded. Okay, so assume maybe we had our CU to be 2 and our CC, um, let me increase the CU. Maybe we had our CU to be 5. And I said earlier that the CU and the CC, they are coefficients, like they don't have units. They are ratio, they come out as a ratio, so they don't have a unit. And maybe our CC is 2. This, with this, the conclusion that we can draw from here is that the soil is well graded soil, and it is mostly for gravel or gravelly soils. So for gravels. So you have it as maybe a well-graded gravel. So this condition is for gravels. Okay. Then for sand, we have our CC to be the same as the CU, just that we've increased the limit of the CU a bit to be greater than or equal to 6. So it means that if you are classifying a sand, then it means your CU should be greater or equal to 6, and which is a well-graded soil. For it to be a well-graded soil, your CU to be, you need it to be greater than or equal to 6. And your CC should be within the range of 1 and 3. It means that it can be 1 point whatever to 2.99. Okay, and the CU should be from 6, 7 upwards. That's for sand. Okay, so we have our SW to be representing well-graded sand, SC to be clay sand, SM to be silty sand, and we have a lot of them. We have some that combines dual symbols to classify, others to use these 2 symbols to classify them. Okay, let's bounce straight to classify 1 or 2 and see what we have for today. Okay. So this is the chart that we use to describe soils in Unified. So with this chart, you see classification procedure, and under that, you can see a coarse-grained material. And as I earlier said, the coarse-grained comprises of the sand and the gravel. We have grain size distribution. We have fine-grained material. Then when you get into it, you can see in the first column, we have coarse. The second column, we have gravel, and so on and so forth. You see, under the coarse, we have more than 50% retained sieve number 200. We are going to explain that, so you get the understanding. Okay. So let's pick this very example and go through that and see how it is going to turn out. We have the percentages of passings. So this result is coming from our particle size distribution that we did, the table that we did, percentage retained, and those tables. That's where these values are coming from. Okay, so with these values, they are going to help us classify the soil. So with this, it was given that the percentage that passed sieve number 200 is 30%, and the percentage that passed sieve number 4 is 70%. And mind you, the larger the sieve number, it means that the smaller the sieve, the size of the holes. So sieve number 4, it means that it has a very large holes, like in the sieve, compared to sieve number 200. Sieve number 200, I think that is the least among the standard sieves that we use. Okay, so maybe let's take this to be sieve number 4. It has larger holes than sieve number 200. So sieve number 200 will just be beneath sieve number 4. Let me draw it properly. Okay, so it's like this. This comes, then the next one. So it has been arranged like that. This is number 4. The number 4 comes first. So sieve number 4. And maybe this is sieve number 200. Okay. So the sieve number 4, as I said earlier, it has very large diameter of holes, very large ones. Okay. And the sieve number 200 has very tiny holes in them. Okay. So this illustration is just giving you an idea of how the sizes look like. And beneath that, we put a pan under it to receive the fines that will go through sieve number 200. Okay. So this is what happened. After testing with sieve number 4, we realized that 70% of the soil passed through sieve number 4. So they went through like this. And if 70% pass through the first sieve, it means that 100 minus 70 ended up being on the sieve number 4. So this is going to give us what? 30%. Please, is that clear?
Yes, sir.
Okay. So it means that 30% ended up retaining on sieve number 4. It couldn't go through sieve number 4. And if you have any percentage that will retain on sieve number 4, it means that that percentage is a gravel, or any percentage that will not be able to go through sieve number 4, it means that the particles sizes are very large, and that constitutes gravel, or the gravelly part of the soil. So from here, from this first equation, we can identify that our percentage of gravel is what? 30%. Please, is that clear?
Yes, sir.
Okay. So our percentage gravel, we've determined that to be 30%. And let's move on. The percentage that's past 200. So the 70% will come here. The 70% of the soil will come here. It will come to end up on the sieve number 200. And the percentage out of that 70% that will be able to pass through sieve number 200, we consider that portion to be fines. So the very fine particles will be poured here into the pan. Okay. So the percentage that passed sieve number 200 is what? 30%. So this 30% is the fine part of the soil. So with that, we straight away get our fine portion of the soil. So the fine is 30%. Please, is it clear? Can I continue?
Yes, sir.
Okay. So 30% is the fine, and we have the gravel to be another 30%. And with these two, out of 100% that we are considering, so we have our fine now, we have our fine, we have our gravel. What we need now is our sand. We are dealing in percentages. So what do you think the percentage of sand will be, please? I'm waiting for your answer. Yeah, Ray. Ray, are you there? So we are dealing in percentages. We have 30% fine and 30% gravel. We want the percentage of sand. Yes, Kobe, are you there? Can you help us with that?
Yes, sir.
So
Um,
what is the percentage?
40%.
40%.
Yes, sir.
Okay, sir. Thank you very much. So 40%. Please, I hope you all get why he had 40%.
No, please.
Okay, so the total thing is 100%. So 100 minus the percentages that we've gotten now, which is the 30% minus another 30%. And this is going to result in 100 minus 60% or 100% minus 60%. And this will end up being 40%. Please, is it fine now?
Yes, sir, it's clear.
Okay, sir, thank you. So you do this before you even go to the table, because if you don't do this, the table, you are not going to sit up whatever you'll be doing. So you do these calculations to find the percentage of the gravel. And I said the percentage of the gravel is the percentage retained on the sieve number 4. And you find your percentage of fine, which is the percentage that passed sieve number 200. Keep these two things in your head. And if this drop, it is a very easy question you can get. So with that, we now have all the things we need. Please, any question? before I move on? Any question? Okay. So if there are no questions, then I think I can continue. So we have sand to be 40%. We have gravel we have our gravel to be 30%, and we have our fines to be also 30%. So you, after getting them, then you write them somewhere like this, or how convenient it will be for you. So fines 30%. Okay. So this is what we have. And what we are going to do is from here, or is it before we classified it, I told you earlier that the coarse grain soil, it's comprised of what? The sand and the gravel. Please, have you seen it?
Yeah.
So if you want the coarse grained, from here, you just add the sand and the gravel. So sand plus gravel. Please keep these things well, because I found it very hard to come by this. Before I understood this, I watched a lot of YouTube videos before I could understand this. When he was teaching in class, it was just a sum of like he crammed put everything together, and I couldn't get the understanding properly from class. So it's a very good concept I'm giving you. So you have 40% sand, then plus 30% gravel. This is going to give you 70% coarse. Okay, so we have the coarse grain to be 70%. Please keep it well. We are going to the table right away. Okay, so on the table, I'm going to clean here. So keep the values for me. I might ask for them, or let me just put it somewhere here. So the cost is 70%. Okay. So you come to the table. Then the first column of the table, this is the first column of the table. The first column of the table is asking us to check whether the particle or the soil sample is coarse or fine. So we are considering this coarse and this fine. So whichever picks the description, or whichever goes with the description, then we follow its path. You can see there's a red line dividing these two. It means that the upper half is for the coarse and the lower half is for the fines. Okay. So let's continue. So what are we having? We have, if you have what, more than 50% retained sieve number 200. So if you have more than 50% retained on sieve number 200, then what is that? Let's go and find the number that's retained on sieve number two. So whatever that will retain on sieve number 200, it means that it is either sand or gravel. Because if you put gravel on sieve number 200, because of its smaller size, or the small size of it, the small size diameter of the sieve, it will not be able to allow gravel or sand to pass through. Sieve number 200 only allows fines to pass through to get into the pan. So more than 50% retained sieve number 200. It means that if you have your cost to be greater than your fine, you are definitely going for the cost. We have our cost to be what? 70%. And our fine to be what? 30%. So this is the first column. That's basically what it is saying. The one with higher percentage, either the cost or the fine. Here you are not comparing sand or gravel. You are comparing cost and fine. So if you have more percentage for cost, then it means that we are taking the upper half of the table. If you have more percentage of the fine than the cost, it means that we are going by the lower part of the table. Please, is that clear? Hello?
Yes, sir.
Okay. So here we have 70% of the cost, and that suggests that we are going straight for the upper half of the table. Or if I should explain further, we can find the percentage retained, the percentage that will be retained on sieve number 200 is the same as the percentage for the sand and the percentage for the gravel, which in combination gives you the coarse side of the coarse grained particles. So it's a matter of just comparing the coarse and the fine. If the coarse has a greater percentage than the fine, you go for the upper table. If if the fine has greater percentage than the cost, you go for the fine. Basically, that is it. Okay. So we can find out that we have 70% of the fine, the cost, and that is far more greater than the fines. So we are just going straight to the upper table, the upper half of the table. Okay. So we've crossed this side and we took this. Okay, let's go to the next column, this column. We are dealing with the upper half, this half of the table. Okay, so it is saying that if it is gravel, here it is just telling us if we have more gravel, we should choose the top one. If you have more sand, you should choose the down one, which is the sand. There are a lot of English here. Let me just explain. So more than 50% cost fraction retained on sieve number 4. So they are just asking if you have more than 50% of the coarse fraction retained on sieve number 4. The coarse fraction is what? 70. Please, do you remember? We have the coarse fraction here. It's the same
Yes,
as
sir.
the percentage. So fraction is the same as percentage. So the coarse fraction or the coarse percentage, if the coarse fraction, which we have it to be 70%, if you have more than 50% out of this coarse fraction, which is made of gravel, then it is made of gravel and sand. If you have 50% of that retaining on sieve number 4, then you go for gravel. So 50% of 70, 70%, that's what they mean. But it basically means that if you have more of gravel than sand, go for the top one. If you have more sand than gravel, go for the down one. So let's check whether we have more than 50% coarse fraction retained on sieve number 4. So the fraction that was retained on sieve number 4 is the fraction of that's the gravel. We had it to be 30%. And if we take 50% of the coarse fraction, it means that we should just divide this by half, which is going to be what? 35. Is that not it?
Yes, sir.
So half of the coarse fraction is 35%. And we have 30% retaining on sieve number 4. So it means that it is less than that. Do you get it? Hello? It says it is
No, sir.
gravel. It is gravel if you have more than half of the coarse fraction retaining on sieve number 4. And I said half of the coarse fraction, that's 50% of the coarse fraction, is 35. Do you get it? And the fraction that's retained on sieve number 4 is 30. So if we should have gotten this 30 to be greater than half of this coarse fraction, then we would have gone for gravel. Please, do you get
Okay.
it? But
Yes, sir.
if we are not having half of, we are not having the coarse fraction, we are having the coarse fraction to be more than the fraction that was retained on sieve number 4. So it means that we are not going for gravel. We have to come and check for sand. Please, is that clear?
Yes, sir.
Okay. So it's just that if it is gravel, we have sand to be 40% out of the coarse fraction, and we have gravel to be 30%. So here, you shouldn't waste time. What it means is that this one, it means we have more sand than gravel. This one is for sand. This is for gravel. So no matter how you go about it, you end up getting the same answer. So straight away here, the one with the highest percentage, you just choose that one. And that is sand. So you just choose this. You don't have to do this whole lot of calculation before you even miss a step. Or if you can go through that calculation too, it will land you at the same place where you take half of the coarse fraction, which is 70, and compare with the percentage retained on sieve number 4, which is the percentage of the gravel. If the percentage of the gravel is more than the percentage of half of the coarse fraction, then you choose gravel. If the percentage of gravel is less than half of the coarse fraction, you choose sand. So that is why I chose sand here. Or you can just go by their percentages. If you get here, it's like when we were comparing coarse and fine. Wherever you have your higher percentage, you just go by that. Simple. Very, very simple. Please, is that clear?
Yes, sir.
Okay. So let's continue. So we are done with the first two columns. Let's get to the third column. So we chose this side and it came this way. So we are here. You see there is a blue line indicating that you can't go to the top again. If you come down here, everything is going to be in this direction. You won't be permitted to go up here again. So that's why there is a blue line separating the gravelly parts and the sand parts. A very simple concept. Very, very simple. Okay. So let's continue. So what do we have? It says what? Less than 5% fines, more than 12% fines. So what do you think it is? We have our fines to be 30%. Kobe, what are we choosing here?
So more than 12% fine.
Okay, that's very good. Excellent, excellent. Okay. Then there is no line separating the two. Do you get it? There is no line separating the two, but if you choose more than 12% fines, it means obviously you are coming this way. So you should know that this side goes here and this side too comes here. So what is next? It says what? Below A line, above A line. And what can we use to plot that below A line and above A line? So we come and check here, this graph. That is where we have the A line. Okay. Let me clean this whole thing. Okay. So you want to use this chart. So with that, we have to look for the liquid limit and the plasticity index in order to determine whether it is above A line or it is below A line. So we go to the table again. Can you see we were given liquid limits and plasticity index values? They are here. Please, do you see that?
Yes, sir.
Okay.
Mm-hmm.
So our liquid limit is 33% and our plasticity index is 12%. We are going to plot that. And after plotting, we indicate whether it falls above the line or it's below the line. Okay. So we are going to plot 33 here, 33 on the horizontal, and 12 on the vertical. Okay. So 33 on the horizontal, it is going to be plotted somewhere here. And the 12 is going to be plotted somewhere here. So where do you think they will meet? Will that be above or below the line? This is where they are meeting.
Above.
Okay, very good. So it is clearly above line A. And we've classified our soil to be SC, which is it sandy clay or clay sandy or something like that? Okay, clay sand. Then if you have the percentage of gravel or sand to be greater than 15%, think, okay. So your SC is just fine. You can leave it as SC or clay sand. This one, it's not compulsory to add the with gravel to it, but it makes it a bit formal. So you just check. You now know that you have sand. So if you want to know whether the sand has some mixture of gravel, you just check whether you have 15% of the gravel. You have the gravel amount that you calculated to be greater than 15% or equal to 15%. If it is greater or equal to 15%, then it means that you have some small amount of gravel in within your clay sand. Thank you. So we are going to classify the next. And this formula too, you can use it to check whether it is above or below the A line. How do we do that? How do we do that? You have to put where there is a liquid limit, the LL, you put the liquid limit there. So you put 33 here. Please have you seen it? And the PI, it remains, you put it here, 12. So you check whether this PI, if it is greater than the whole of this place. If it is greater than that, then it means that it is above A line. If it is less than that, it means that it will fall below A line. Please, am I clear? So we had the
Yes,
PI to be 12. And after putting your liquid limit, which is 33, subtracting 20 from it, you will get 13 times 0.73. I think you will get 9.49. So 9.49. And if you have your PI to be greater than the whole of that calculation, it means that it falls above A line. You can equally plot the points as we did, and you can check easily how the points or the coordinates are moving. Okay, let's do one classification and move on to AASHTO, if time permits us. Okay, I want to finish the
Hello.
soil. Hello.
Hello. Yes.
Yes.
So if the PI, the 12,
Yeah.
if it was less, then it would have been below A line.
Yes, please. Maybe if here was to be 13, below A line.
Okay, all right. Okay, thank you.
Welcome. Please, any question? And this formula is normal. They normally give it in the formula sheet, so you can check it out for them. Or if you can memorize that too, I think you wouldn't have a problem with anyone, should in case it doesn't come. Can I continue, or there is a question?
No, please. Yes, you can continue.
Okay, thank you very much. Okay, so I think we did, this is what we did. Okay, fine. Let's try this. Let's try and see whether it conforms with what is here. One time I was complaining something to them. So our percentage passing sieve number 200 is 30, and that automatically gives us the percentage of fines. Please, do you remember?
Yes, sir.
Yes, please.
Okay. And the percentage retained on sieve number 4, retained, I didn't say passing, retained on sieve number 4 is our gravel. So what is that percentage? We have passing to be 60. So it means how many retained? Out of,
40%.
okay, so we have 40% to be our gravel. Straight away, we don't waste time here. Okay. So if you have 30% to be your fines, 40% to be your gravel, then what percentage is the sand?
30%.
30%. Please, do you all get it? Or we are moving
Yes,
too
please.
fast?
It's okay.
Okay, fine. So this is the information we have. And what is our cost? Our cost fraction or cost percentage?
70%.
70. Okay.
Yeah.
Sure. So let's move on. So the first column between cost and fine, which one do we have? We have 30% fine, we have 70% cost. It means we have a lot of cost fraction than the fine fractions. So we choose the cost. Please, do you get it?
Yes.
Yes, sir.
Okay, so the gravel and the sand, what do you choose? You give me a reason after that. Yeah, Kobe. Osnad, are you there?
Sir, I'm here.
So choose between the gravel and the sand and give me a reason.
Sir, I would choose gravel
Because
because more than 50% of the cost, you get 35%.
more than 50%
More than 70%, half of the,
cost fraction.
yes, will give us 35.
Okay. And the gravel is more than 35, right?
Yes, sir.
Okay. A very good explanation for that. Thank you very much. Okay, so here we choose gravel because when you take half of the cost or 50% of the cost
So,
fraction, you get,
a question, please.
okay,
Yeah, so 50% of the cost fraction was 35.
yes,
And it was less than
gravel.
the sand.
No, we are comparing, it
That's
is
why they
greater
didn't
than the
take the
sand.
sand.
It is greater than the sand.
Oh,
If
it's
you are
sorry,
to,
it is greater than the sand. Yes.
but it is rather less than the gravel.
Okay.
Or better still, you can choose. We are choosing between sand and gravel, the one with the highest percentage. So gravel is 40%, sand is 30%. Do you get it? So you don't have to
Yeah.
bother yourself.
And that
Do
one is easier. But this one
uh,
is a bit tricky.
yes, if
Yeah.
you don't take care, Charlie, you mess some things up. Okay, so let's go.
Because
We
I'm still even trying to get it right now, but I'm confused.
You are so confused.
I'm trying to get the more than 50% cost fraction, but it's still confusing. But the way you said it is fine. About
Okay,
the more and less, yeah. So it's fine.
okay. So more than 50, just take 50% of the cost fraction or half of the cost fraction or half of the cost percentage and compare it the gravel. The
Yeah,
one that
that's
is
35.
greater, you get it? The one that is greater, then if gravel is greater than half of the cost fraction, then it means
Mhm.
that you have to go for gravel. But if gravel is less than half of the cost fraction,
Okay.
it means that you have to go for sand. Do you get it? Ray, do you have any question?
Okay, okay. No, it's fine. I understand now. I understand.
Okay, sure, sure, sure. So let's move on.
Yeah.
So we are here. We are the top here. We are going to less than 5% fines and more than 12% fines. Which one are we choosing and with your reason? Yeah, Osman or Kobe, if you are available. Ray, you can answer too.
Okay, I think we'll choose the more because the fine is basically more than 12%, right?
It is what?
Which is which is 30.
Yes. So we have our fines to be 30 and it is more than 12%. So we choose that. Okay, we have our liquid limit and our PI. Put it in the equation or plot it and let's see whether you get something below or above.
Okay.
I think it's the same
I think it's the
PI.
same equation.
Eh,
Sorry, I mean the
yeah. The same
PI.
equation. I think you get the same thing. Remember, we just solved one like that.
So it will be above. Yeah,
Yes, above.
yeah.
Okay. So we are done classifying it.
But
And we
the first one
I still
wasn't.
don't
Was it clay gravel?
yes, no, the first one was clay sand. This one is clay gravel.
I still don't get how to check whether it's above or
Uh,
below.
You said come again?
Still don't get
Okay,
how
that
to
one
check
was clay
whether
sand.
Yes, the first one was clay sand. It's here.
yeah,
Have you seen it? This is a
yeah.
different question. Hello.
Said I still don't get how to check whether it's above or below the A line.
Okay, so I said that to check whether it is above or below the line, you have to. There are two major ways of doing that. You can plot the PI and then the LL values. Here we have the PI and the LL values given. It will always be given. So if you plot that, your liquid limit, which is the LL, will be on the x-axis or the liquid limit axis to be, it will be here. So 33, somewhere here. And your pi will be on your vertical axis, which is 12. So 12 is between 10 and 20, which is here. So where these two will meet, do you get it? Where they will meet, then you identify whether it is above the line or it is below the line. Please, do you get it?
Yes, sir.
So that's like using your eye to check. And we have an equation that will help you to check too. This is the equation. It's like an equation of a straight line. So the equation, what it does is that when you put the pi here, which is 12, and you calculate the equation of the line with the LL value here, the result that you get, if that result is greater than this, it means that it will fall below the line. If that result is less than this, if that is less than this, like we had 9.49, then it means that it is above. Please, do you get it now? Hello?
He said if you need to get 9.9 means above. So if you get less than that,
If you get less than the pi, it is above. If you get greater than the pi, it is below.
yes, sir.
So always the pi should be greater than this whole calculation to be above. And if it becomes less than that, it will be below. If the pi becomes less than your calculations, or in other words, if your calculations become more than the pi, it means that it is below the A line. Please, is that okay?
Yes, sir.
Thank you very much. Let's kill it.
So, what about the less than 5% fines? Is there a situation where it can fall there? Like, do they like are questions normally set on that? Is it
Question,
possible that I'll say that?
the fines.
Yeah, less than 5% fines.
It's possible. It's
Oh,
possible.
okay.
Everything you see on the table is possible. So less than 5%
Okay,
fines,
all right.
it means that you go this way. Then with that,
Then in that case, we have to deal with the okay.
you'll be given your CU and your CC in order to classify them. So if you have this, then it's a well-graded gravel.
Okay.
If you don't have something like that,
If it
it's a
doesn't
poly.
fall, then it's not satisfying.
Yes, please. Is there any question again?
So the whole concept behind this is just to classify the soil you've
Yes,
been given.
please. Yes, please. You are just classifying the soil.
Oh, okay. So they won't give you any other columns apart from these very columns we are seeing on the screen right now.
Yes, yes. They are the only thing you will see. If you are to go by, this
Oh,
is
okay.
a unifying method.
Okay,
So
okay. All
there is
right.
another method to the AASHTO method. So they will state the method we should use to classify the soil.
Okay. So Marvin, I think we should also go and learn maybe another time we can learn the AASHTO method, just in case.
We should go over this.
No, I mean the AASHTO method, just in case we can go over the AASHTO method.
Yes,
We
after
can
this,
brush through.
that's what we are going to do.
Oh, okay.
So I'm just jumping straight to that. That one is very very simple than the unified. The unified is very terrifying. Like the AASHTO is the best. Like you do and you feel like you've done something. Very simple. You just have to know this formula that I've put on. The GI equal to F200 minus 35 into bracket 0.2 plus 0.005. Your liquid limit minus 40. Have you seen that equation? I'm sharing.
Yeah, this one I chewed it.
You remember this game, right? Is
I
it
remember one.
in the Miss Sam or something like that?
Miss him.
Yes, Miss Sam. And
Yeah.
I don't know whether the formula
Think
was given
we
or
I think we were lucky. The formula was given, so
oh okay.
yeah, I'm sure. Yeah, if I remember.
Oh, it's actually a simple something, but if you don't take care, a lot of people couldn't solve the GI, and if you are not able to solve the GI, Charlie, you are doomed.
Um, it's the most
So
important thing, eh?
yeah, that's
Okay.
it ends the whole classification thing. Like so, the GI
Oh,
is
okay.
the F200 is just the percentage that is passing the 200 sieve, and the PI you know already is your plasticity index, and the LL still remains the liquid limit.
Liquid limit.
Yeah. So there are some key factors that you need to know. There are about three. The rules governing the GI. The GI is called group index. Group index, sorry. Group index. It's written on top here. Okay. There is an empirical formula used to further evaluate soils within a group. So it's like it classifies the soils into subgroups after having a general group. If you want to classify it into subgroup and it's compulsory, you have to classify that into a subgroup, else you've not really done anything. Okay.
Okay.
Yeah. So your GI, you have to round it off to the nearest whole number, assuming you have 6.57 after calculating your GI. You have to approximate it to the nearest whole number, which is 7. And if you have negative number to maybe negative 6.66 or negative 6,666, you still have to approximate it to 0. And I think that's the basic thing. And you can get GI to be 0 too. And GI 0 is still 0. You can't do anything about it. Is there any question here? And there is this important statement here. If you are rating a pavement subgrade, the subgrade of a pavement, it is the inverse of the GI. So that's one of the most important informations about it. So 1 over GI, it gives you,
Hello?
hello.
Yes, sorry. I wanted to ask something. They said the GI is rounded off to the nearest whole number
Yes,
and appended in parentheses.
a very
Is that
important
also
one.
not an important factor?
A very important one. I nearly skipped that. But I would have introduced it
Okay.
in our calculation. So you just put it
Okay, all right.
in a bracket. Like if you get 0, it's 0. After naming whatever A7, A6, A what? So maybe A70, A6, whatever into bracket 0 is a very important statement. You can't just add or append the 0 without a parenthesis or a bracket sign. Like you can't do it A70, like it wouldn't make sense. Someone would think it's A70 or something. So you have to find a bracket and put it inside. Okay, so can I move on?
Yes, please.
Okay, a very quick one. So I think when the unified comes, you can do it. And this is even the simplest. So this one that I don't have any problem here. Okay,
Can
okay.
you get the question so that we saw like maybe an exams question or something?
Oh yeah, I have a lot of that. You don't have a problem.
Yeah, so that we can solve at least, some of
Yeah.
them.
So basic, we have one here. Can you see it? The one I'm displaying, the example.
Yes, please. Yeah.
Okay. So what we are going to is just you are going to just follow instructions and put them under groups. So maybe let me see. They didn't give any example before this. So if this is how we move from left to right. We move this way, and here we move this way. So
All
you
right.
come, your number 10 sieve, the percentage passing. Have you seen percentage passing here?
Yes.
Okay, so percentage passing number 10 sieve. If maybe we have our percentage passing number 10 sieve to be 30%. 30%. Then we come horizontally. And here under this A1A or capital A1 small a, we have the maximum to be 50 or 50%. It means that it has qualified for A1A. Do you get it?
Yes. Yes.
Okay.
Okay.
So after qualifying for this, then we come down where this arrow is coming. We come and check sieve number 40, percentage passing sieve number 40. So if percentage passing sieve number 40 is maybe 60%, if it is 60%, then it means that we will still go horizontally. And here we have 30% to be the maximum, but it crosses that. It is 60. It is not something less than 30. You get it?
Yes, please.
So you can use your pencil or your pen to cross it that it doesn't belong here. Then you go to this place. Here the maximum is 50. And we are having our the percentage to be 60%. It doesn't also belong here. Please, do you get it? Osnad,
Sir.
you get it?
Yes, I
Yes,
get
sir.
it.
Kobe, are you there?
Yes, yes.
Okay. So it is greater than 50%. So it doesn't belong to this 50 marks. So you just cross it. Then you come here. The minimum is 51. It means that it's it covers 60% as well, because if the minimum is 51, it means that it takes everything above 51 going, and we have 60, so it qualifies for this. So we are now under this. Please, do you get it? We are now under A3. It has to qualify for everything. So we go to the next table. That is number what? 200. So number 200, let's come down. We come down straight to this. And maybe assume that the percentage that's passed number 200 is 25%. Please, we don't go back. Like, we don't come here again. Wherever we land, like, you see, we landed on this 51 minimum. We just come down straight to its next characteristic. So number 200, and the number 200, the maximum that we should have for it, for the classification or for the soil to belong to A3, is that we should have the percentage passing number 200 to be 10% maximum. But here is the case, we have 25%. So what do? We just go forward. We don't look backwards. We are looking forward like that. So after looking forward, what are we seeing? We are seeing that the next, just the immediate classification or family has a percentage maximum of 35%. Please, can you see that?
Yeah, please.
So it means that this qualifies for that, and we have to take that. We don't go again. We've landed on something that is giving us positive results. So we just look straight like that. So looking straight down, what do you find? Liquid limit. And the liquid limit is maximum of 40% or 40 mass. And assume we have our liquid limit LL to be maybe 50%. So if it is, or let me make it 30%, so that we will just maintain something for some time. So let's make it 30%. Maybe the liquid limit is 30%, or it can be 12%. Anything. Do you get it? So if it is 30%, then it means that we've qualified for the next characteristic. We won't go this way again. We won't go this way again. We just come straight to the next characteristic and check whether it will pass. So assume our PI to be maybe 12%. So if our PI is 12%, then does it pass for plasticity too? Hello?
Yes, hello.
Our
Please come
PI,
again.
the plasticity index here, we are at this characteristic, and we've come straight and we are seeing 10% maximum. And I'm asking whether
Yes.
the PI, which is 12%, pass for the 10% maximum. Does it pass?
Yes, it passes, it passes.
Are you sure?
Yes, sir.
Under this family,
Yes, it
it
passed.
is it is allowing 10% maximum. Like the maximum of plasticity index should be 10%.
Yeah.
And here is the case that we have our plasticity index to be 12%. And I'm asking whether it pass or it doesn't pass.
Ah, okay. You mean whether it's okay? No, it doesn't pass. It doesn't pass.
Yes, it doesn't pass. The reason being that the 12% is more than the limit that they've given us.
Yes.
Do you get
Yes,
it?
please.
Okay.
Yes.
So coming here, it doesn't pass. So what do? You have to move horizontally to the immediate limit. The immediate limit too is 10% maximum. So that part too, it doesn't pass. So we continue our journey. Please, do you get it?
Yeah. Yes. Please.
Okay.
Question.
Question.
Yeah. Yeah. What if on the rule it doesn't fall on any of the maybe the number 10 or number 40 or number 200? It doesn't fall or on anything on the rule. Is that possible?
No, it's not possible. By all means. Okay, maybe
It has to
it's
fall.
it's not it is not possible for number 200 for you to get something like 60, because you can see all the maximum values. I think 35 is the maximum you can get. Do you get it?
Yes.
So it's something that you can
Yeah.
get above that.
Oh, okay.
Yeah, I think I didn't ask that question though, but I have the feeling that you can't get above 35.
Mhm. Okay.
Yeah.
Based on how the question will come, they won't give you anything
No,
outside that range.
that range,
Okay.
no, they won't give you.
Yeah, I understand.
Okay. So we are going horizontally again. And here the minimum is 11. It means that it accommodates values of 11 and above. And here is the case we have 12. So it passes for here. So if it passes for this side, then our next characteristic, do we have any? Okay. So this is where our final destination comes to an end. The 11 minimum.
Mm.
So under the 11 minimum, what's the class that you are having? You just check straight. The class is A2, A,
826.
A26. So you have this, your beautiful class, and you have to bring your bracket and put your GI inside. So we have to calculate our GI. So you know how we calculate the GI already. So it's a very
Yeah.
simple task. So the GI is F200 minus 35. So after calculating this, you just round it and put it at where we have the GI. Please, is that clear?
Okay. So all the parameters will be given to you.
Everything will be given to you.
Okay.
So we can even calculate. I said the number 200, we had what 25%.
Yeah, 25%.
Yes. So you put 25 here at the F200 here.
Okay.
And the LL, I said the LL is 30. And I said the PI is 12. And the F is still 25. So please do the math and give me your answer.
Okay.
So what are we getting for GI?
I got negative.
It's part of the answers. Oh, you dey fear.
Negative, negative, negative 1.3.
Negative 1.3. And what does the rules tell you when you get negative?
So you write zero. Oh, yeah, they said you should write zero when it's negative.
Yeah, zero. Zero. So it's just zero you put here. So we've classified the soil. We are done. Please, is there any question?
What they put you through to get the grade 826. You do.
I can't hear you properly. Can you come again, please?
Yeah, I'm saying hello.
Hello.
Can you hear me now?
I think
Yes,
is that
can you hear me?
yeah.
Okay. I'm saying the final answer that we got, the
Okay.
A2, the 826.
Okay.
Yeah. Yeah. Do you have to show working for it? Or that
Oh
one
no,
is your own personal thing that you do?
your own personal thing. Just that you have to mark it's not compulsory, but you have to mark on it to show some form of working. But at the end of the day, it's your answer that is needed. But the GI calculation, you have to write it. Do you get it? You have to do the actual calculation and let the lecturer know how you came about your zero.
Okay.
Yeah, I think that's it.
Oh, okay.
Yeah.
I see. This one is very, very easy.
Oh yeah, very, very easy. This one
Yeah,
you
but
don't
it didn't come in the exams.
finalize. It didn't come in the end of sem, but it came in the mid sem. Anything can happen to
Yeah. Yeah. Mm. The questions you posted in the group,
uh-huh.
yeah,
Have you looked at it?
the graph, yeah, that's the one I want us to solve. Yeah, I've read through it.
Oh, we've solved it too.
Uh,
Um
that's the one I want us to solve.
eh oh we've okay, we did that I
We
think
solved it.
on Monday.
Yeah, 2 days ago. Yeah.
Oh, okay. I
Oh,
think I
the
wasn't
the video
available.
the video is there. You can check it out and watch it.
Oh, okay. Oh, okay, sure.
Yeah, a very simple one.
Please, I'll
Soil
text you
soil
so that you send
membrane.
me the video to me.
Okay.
Okay, sure.
Charlie, any questions?
Mm-mm.
If there are no questions, I think